Good morning, sir. Hope you're having a nice day. Myself, Vamsi Adiraju, and these are my teammates, Pavan KV, Ritish Nune, and Kaushik SVS. We use two algorithms in this project, starting from SDS algorithm, and our aim is to conceptualize and implement simple data encryption standards using SDS algorithm. And the objectives are to understand SDS symmetric encryption and decryption algorithm, and to implement SDS algorithm using Java programming language, and to discuss about input supplied to the program and corresponding output generated. And here you can see the SDS general structure diagram. And my fellow friend Pavan will explain about the inputs given to the SDS diagram.
Hello, myself Pavan. Now I am here to explain about SDS algorithm, and these are the inputs that are given to the compiler to generate SDS algorithm. And the first step of SDS algorithm is key generation. Here we have to give 10-bit key, which is passed through P10 value. After passing, we'll get some binary value. It is split into two parts. We have to apply left shift to both parts. Then after doing left shift, we have to pass these parts through P8 value. After passing, we'll generate first key, which is used in encryption and decryption. After this, we have to apply left shift 2 times to above parts. After applying, we'll get second key. And here we go. We'll go to encryption. Encryption is nothing but conversion of plain text to 8-bit ciphertext. In this, the first step is the plain text is passed through IP value, and we'll get some output that is split into two parts, and the right part is passed through E/P value. After passing, we'll get some output. We'll perform XOR operation with K1 value. After performing, the left part of the above output is passed through S0 matrix. In S0 matrix, we'll perform row and column operations. Then we'll get S0 value. And the right part of the above output is passed through S1 value. After passing, we'll do row and column operations. We'll get S1 value. And S0 and S1 values are passed through P4, where we'll get some output. After getting, we'll do XOR operation with left side 4-bit of IYP value. After doing this, we'll perform XOR swapping operation. After performing this is the first half of encryption. Again, we have to perform second time. The right part is passed through E/P. After passing, we'll get some output. We'll pass that output, and K2 value will perform XOR operation. And later, the output of the above is passed through S0 matrix. After doing row and column operations, we'll get S0 value. And the right part of the above output is passed through S1 matrix. We'll get S1 value. Later, S0 and S1 values are passed through P4. After passing, we'll get some output. We'll do XOR operation with 4-bit left side of first time. After doing this, the right part of the first time is added to this. At last, we'll pass this through IP inverse. After passing through IP inverse, we'll get 8-bit ciphertext. And this 8-bit ciphertext is the input for decryption. And similarly, in this decryption, we'll do the same, like we'll split into two parts and pass through E/P value. After passing, we'll do XOR operation, and this is the main difference between encryption and decryption, which is we'll use K1 value during encryption at the first, and the K2 value during decryption. This is the main difference between encryption and decryption. After passing, we'll get S0 and S1 matrix and those respective values. After passing, we'll get some output, and later on, we will perform again second time. In the second time, it is passed through E/P value and perform XOR operation. Here we use K1 value for the second time. This is the main difference. Later on passing, we'll get L0 and L1 values. After doing this, we'll perform P4 operation and pass through it. After this, add right part of the first time. Now pass through IP inverse. At last, we'll get the 8-bit plain text which we used during the encryption. That's it. My fellow teammate Ritesh will continue.
Hello sir, this is Ritesh. Coming to the coding part. So first we have chosen all the initialization part. So as my friend said, the inputs for the P10 initial permutation expansion matrix we have taken as arrays. Now we have written a method for initial permutation, and next method is for the function, and now the next method is swap function. So all these methods are used in this encrypt function. So we pass the plain text as input, and we'll get the as input, and we'll get the ciphertext as output. So coming to the decrypt method, so we'll take the ciphertext as input, and after passing through this IP expansion matrix and function, and we'll get the plain text as output. So this function print data, this will print the results. And coming to the main method, here we have taken inputs for the key and the plain text, which will be entered by the user. So Vamsi will run the code. So we are choosing the values which were taken previously, which my friend Pawan showed while he done the manual calculation. So after choosing 11100 as 8-bit plain text, we got the ciphertext as 100100010. So let us compare with the manual calculation. So 100100010. So both are same, is validated. Now let's check for the decryption. So we have given the ciphertext 100100010 as input, and we have got the plain text 1110010, which is our original plain text. Let us see with the manual calculation. It is the same 1110010. So we can say that our code has successfully ran. Now Vamsi will continue about the AES algorithm.
Now talking about the AES algorithm, our aim is to conceptualize and implement advanced encryption standards for AES algorithm, and our objectives are to understand AES symmetric encryption and decryption algorithm, and to implement AES algorithm using Java programming language. And we discussed about the input supplied to the program and corresponding output generated. And here you can see the AES general structure diagram here. And my fellow friend Kaushik will explain the coding implementation of this algorithm.
Hello, sir. This is Kaushik. I'll be explaining the Java implementation of AES algorithm. Here we can observe that I've taken the packages required for the AES implementation, and then we can see that the secret key we have chosen is 123456789, and then the plain text we have chosen is ABCDFGH, and then the first function, encrypt function, is used to encrypt the plain text and convert it into a cipher. You can see the method, and then the next function decrypt is used to convert the encrypted cipher into reverse back into the plain text, and then the print function is shown. Vamsi, can you run the program?
Yes, Kaushik, I'm running the program.
Here we can observe in the output the original plain text is given as original ABCDFGH, and the cipher text after encryption is given in the output, and then the original value is given back after decryption ABCDFGH. Thank you, sir. This is the Java implementation of AES algorithm. Thank you.
Thank you, sir.
Thank you, sir.